In chemistry, there are many types of selectivity. That is, there are many types of selective reactions. There are different types of selectivity. One is chemoselectivity, another is regioselective reaction, and third one is stereoselective reaction, and the fourth one is stereospecific reaction. These are very important reaction in organic chemistry. But today we will discuss the chemoselective reactions. What do you mean by chemoselective reaction? In the presence of multifunctional group in a compound, if it will treat it, react it, that is oxidize or reduce, only which functional group will react, that is called chemoselective reaction. In other words, chemoselective reaction are the reactions in which one functional group will react while other remains intact. यानी केमोसेलेक्टिव रिएक्शन ऐसे रिएक्शन को कहते हैं जिसमें एक फंक्शनल ग्रुप जो है वो रिएक्शन में हिस्सा लेगा, बाकी तमाम जो फंक्शनल ग्रुप हैं वो रिएक्शन में हिस्सा नहीं लेंगे। ये वही रिएक्शन है जिसमें आप एक स्पेसिफिक रिएजेंट आप इस्तेमाल करते हैं, वो रिएजेंट जो है जाके सिर्फ इसी फंक्शनल ग्रुप के साथ रिएक्शन करता है, बाकी तमाम फंक्शनल ग्रुप जो है वो रिएक्शन में हिस्सा नहीं लेते हैं। फॉर एग्ज़ाम्पल अगर हम देख लें इधर, तो इस रिएक्शन में ज़रा आप देख लीजिएगा, यहाँ पर एक ईस्टर है और एक कार्बोक्सिलिक एसिड है. Two functional groups are there. When we treat it with lithium borohydride in the presence of alcohol, and it only reduce ester, while carboxylic acid remain intact. हाइड्रोजिनोलिसिस हो रही है यहाँ पर. हाइड्रोजिनोलिसिस आप जानते हैं एक प्रोसेस है जिसमें यानी ब्रेक डाउन होता है ये ग्रुप, यानी ईस्टर की ब्रेक डाउन होती है, यानी रिडक्शन ऑफ ईस्टर टेक्स प्लेस. ओके, so lithium borohydride in alcoholic solution will reduce ester only. In fact, it has useful selectivity for esters or amide, that is lithium aluminum hydride does not have. अगर हम लिथियम एल्युमिनियम हाइड्राइड यूज़ करें इसकी जगह, तो ये जो है इसमें सेलेक्टिविटी नहीं होती है, लेकिन हम लिथियम बोरोहाइड्राइड अगर हम इस्तेमाल करते हैं तो इट विल ओनली रिड्यूस ester instead of carboxylic acid. Okay, so this is a specialty of this reaction. So this is all about chemoselectivity. But if we go further, अगर हम थोड़ा सा आगे जाके इसको मज़ीद देख लें, तो आगे और भी बहुत सारे रिएक्शन है जहाँ पर केमोसेलेक्टिव रिएक्शंस होते हैं. फॉर एग्ज़ाम्पल हमारे पास एक मशहूर रिएक्शन है, आप इसको देख लीजिएगा. सपोज़ इस रिएक्शन में आप देख लीजिएगा, यहाँ पर हमारे पास एक साइक्लोपेंटीनोन है. इस साइक्लोपेंटीनोन में देयर आर टू फंक्शनल ग्रुप्स आर देयर. You see here there are two functional groups. Okay, so if I will there is a chemoselective reaction, we are carrying out a chemoselective reaction in which one functional group will react while other functional group remain intact. Suppose if we use sodium borohydride as a reducing agent, it will only reduce the double bond of cyclohexanone. As a result, cyclohexanone will form, and it will further reduce it, and then it convert into alcohol. But initially, through chemoselective reaction, it will only reduce the double bond. But if I want to just reduce carbonyl carbon, alpha beta unsaturated carbonyl carbon, if I want to reduce only carbonyl carbon instead of this double bond, then sodium borohydride will use with selenium trichloride. When this reaction carried out in sodium borohydride is treated in the presence of selenium trichloride, As a result, only carbonyl group will reduce into corresponding alcohol while this double bond remain intact. So this is called chemoselective reaction, in which one functional group will take part in reaction while other functional group remain intact. Okay. Similarly, another famous reaction, Wolff-Kishner reduction, carried out, which is a famous chemoselective reaction, in which in this reaction there are multiple functional group. One is carbonyl group and another is double bonds, that is benzene ring, are present there. So Wolff-Kishner reduction carried out, in which hydrazine react with this compound. As a result, it only reduce carbonyl compound, carbonyl group into CH2. Okay, while benzene ring, that is double bonds, remain intact, इस पे कोई effect नहीं होगा. This is a reduction for aldehyde and ketone. Other reducible groups such as carbon-carbon double bonds and nitro groups usually remain unaffected under the condition of this reaction. So this is called a Wolff-Kishner reduction. So this is another example of chemoselective reaction. Wolff-Kishner reduction is the reduction of carbonyl compounds to hydrocarbon by heating them with hydrazine hydrate and a base. In this process, the carbonyl group gets converted to CH2 group via nitrile or NH2, and a nitro group, a nitrogen gas evolve out. So the reaction is basically converting carbonyl groups to methylene groups. To drive off the nitrogen gas, which is a side product of the reaction, it is necessary to use a high boiling point solvent like ethylene glycol. यानी इथाइलिन ग्लाइकोल ऐसा सॉल्वेंट इस्तेमाल किया जाता है ताकि नाइट्रोजन गैस इवॉल्व हो सके. तो इस वोल्फिकेशनल रिडक्शन में आप जो है सीधे आप कार्बोनाइल ग्रुप को जस्ट CH2 में कन्वर्ट कर देते हैं. The another important chemoselective reaction is Clemensum reduction. Clemensum reduction is another example of chemoselective reaction, in which one carbonyl group is converted into CH2 in the presence of zinc amalgam with HCl. So this method and Wolff-Kishner have same application, but the only difference is that this is if the compound is acid sensitive, then Wolff-Kishner reduction were carried out, and if the compound is base sensitive, then Clemensum reduction were carried out. So in short, Clemensum reduction also rather violent and really reasonable only for compound with just the one functional group. If you use zinc metal dissolving in hydrochloric acid, that is zinc amalgam with HCl, as the metal dissolve, it gives up two electrons in the absence of something else to do. These electrons would reduce the H plus in the acid to H2 and give zinc chloride and H2. But in the presence of a carbonyl compound, the electrons go to reduce the carbon oxygen bond. So this is another example of chemoselective reaction. In this reaction, only carbonyl compound reduce into CH2 while carbon-carbon double bond of benzene remain intact. So I think you have understand the chemoselective reaction. Chemoselective reaction are the reaction in the presence of multifunctional groups. Only the selected one functional group take part in reaction while other functional group remain intact. As a result, we get the desired product in the presence of suitable reagents. So this is all about chemoselective reaction. If you have any question regarding chemoselective reaction or Clemensum reduction or Wolff-Kishner reduction or any discussion or any point you need to discuss, kindly comment in this video. Thank you very much.